Well, so welcome you all to the next session of S.J.Sarkar's class. So today actually we would be discussing the fundamentals of electrical engineering, or rather more precisely if I could say, if we are going to discuss about the fundamental of electrical circuits. So we would be discussing the Kirchoffs law in basics, and then we are trying to understand that how basically we are going to apply this Kirchoffs law for different circuits. So let us start with this particular series arrangement. So if you could come across what exactly you could see there, it is having two resistance R1 and R2 which are in the series, and V1 and V2, they are basically the voltage drop across R1 and R2. The applied voltage is V, and I is basically the current that is being drawn by the system. So for this particular system, what we could write, we can write that the equivalent resistance will be equal to R1 plus R2. It's a known thing what we know. In case it is combination, it would be equal to this one. So if we are going to multiply this equation both sides by I, so what we could write, IR equivalent would be equal to IR1 plus IR2. This is what we are going to get. Now what about the VI into R equivalent? This is basically the applied voltage V, because we could find out R equivalent equal to V by I. From that you could find, so this is basically equal to V. What is I into R1? That is basically the voltage drop in R1, so that is V1 plus what is V2, that is I into R2, voltage drop across R2, so it would be V2. So what we could see, that the applied voltage is equal to sum of the drop. So in other way around, if I am going to write it, what we could write there, that V minus V1 minus V2 is equal to 0. So this expression, what we are getting, this is basically what, this is justifying the Kirchoffs Voltage Law. So what actually is happening, that the sum of all voltage in a particular mesh or loop, that is going to be 0. So V is the applied voltage and V1 and V2 they are the drop. So in other way around, what we could also say, that the applied voltage should be equal to the sum of drops in the circuit. So this is basically the Kirchoffs voltage law. Now coming to the next arrangement, we are having two resistance in parallel to a voltage source, with I1, I2 be the current through R1 and R2 respectively, and I is the total current that is actually passing through it. So what we could write, R equivalent will be equal to R1 R2 by R1 plus R2. This is known to us. Now we are multiplying both sides by I. So it would be IR equivalent will be equal to I into, can I rearrange the thing and write it in this way, 1 by R2 plus 1 by R1. So what basically we are doing, we are taking this R1 by R2 in the back side. So basically the step jump is done. It would be something like this one. This IR1 will be equal to I into 1 by R1 plus R2 by R1 R2. So we'll be doing that, and from that we are getting to this one. Now what is I into R equivalent? That is basically V. So V would be equal to I by 1 by R1 plus 1 by R2 we are getting. Now, what we could write from that I will be equal to V into 1 by R1 plus 1 by R2. That I could write V by R1 plus V by R2. So we are reaching up to this particular point. Now what actually signifies V by R1? If you could see, V by R1 is basically I1 and V by R2 is basically I2. So what I could write there, that I should be equal to I1 plus I2 we are getting. Or in other way around, what we could say, that I minus I1 minus I2 will be equal to 0. So this is basically what we had come across is the Kirchoffs current law. So what actually is going to say, that in case of this particular node, this is a node is basically the point where we are having multiple, more than 2 number of circuit components are connected. So one voltage source is connected, 2 resistors are connected. So this is a node. So in this particular node, the total current should be equal to 0. That implies that whatever current is coming inside, that should be equal to the total current that is going out, that is I1 and I2. So this is basically the Kirchoffs law. Now, suppose I want to apply this particular knowledge in a particular circuit. Let us suppose I am having this particular circuit, and what I want to apply this knowledge of Kirchoffs law to solve that what would be the current through this load resistance. So our objective is to find out what is IL. We want that by using Kirchoffs law. So we could have 2 Kirchoffs law, one is KVL, one is KCL. Now this KVL is also called mesh or loop analysis. Why mesh or loop? Because it is basically applied in a particular mesh or loop. And this Kirchoffs current law is also called nodal analysis, because we are applying the thing in a particular node. So in this particular arrangement, what we have to find? We have to find out IL. And the question is saying that by using Kirchoffs law, we have to find out this IL. So how we could find? We are having 2 Kirchoffs law, Kirchoffs Voltage Law and Kirchoffs Current Law. We are having. So let us start with Kirchoffs Current Law first. Let us understand what actually is going to happen, and then we will be applying that Kirchoffs Voltage Law to understand how we could find out IL in this particular arrangement. So let us try to understand. So in case of this Kirchoffs current law, basically what we need to do is to decide that what about the direction of current. So let me assume that this is I1, this is I2, this is IL. So this is the first thing. And what are the nodes? There are 2 possible nodes. This is one particular node and this is one particular node where we could apply this KCL. So what we are doing, we are assuming that this potential of this node will be at 0 volt, and the potential of this particular node is say V. Okay, so if I could have a circuit connection like this one, so how we could proceed to find out IL? So just try to visualize it. See, in this particular node, incoming currents are I1 and I2 and outgoing current is IL. So what we could write? That I1 plus I2, that it should be equal to IL. Now what is I1? I1 is current passing through R1. So that is basically what? Potential difference across R1 divided by R1, that is the current. So what is potential at this particular point? I am assuming this point to be 0. So this point will also be 0. So we could say that this point potential would be V1. So this point potential is V1, this point potential is V. So what I could write? I could write it in this way: V1 minus V by R1 plus I2. Now what is I2? I2 is current passing through R2. Potential at this particular point will be V2 and potential at this point is V. So what about the potential difference? That would be V2 minus V by R2, should be I2. So it would be V2 minus V by R2. That should be equal to IL. Now IL, we are having two resistance, R3 and RL. This point potential is V, this point potential is 0. So what is the potential difference? That would be V minus 0 divided by the resistance. So what we could write? We can write V minus 0, that is basically V by R3 plus RL. Okay, so we are getting this expression where V1, V2, R1, R2, R3, RL, they are known quantity. So if we are going to simplify this, we could find out V will be equal to some value. We'll be getting it. Now, once we are getting V, we can find out IL by using the relationship V by R3 plus RL. Okay, so this is the way by which we could get the answer if you are going to apply the Kirchoffs current law. Now, the question may come to your mind that I had considered the action of current would be something like that, and then we are getting the same, this particular result. What if I am changing the direction of current? So let me assume in a different way. I am having the similar circuit. I am assuming one current is, this V1 is much higher. So what I am considering that a current I1 is passing in this direction, I2 is passing in this direction, and IL is passing in this direction. So in that case, what is going to happen? Again, this node voltage will now become V dash, and I am assuming this node to be grounded, which is 0 volt. So we can write I1 is the incoming current, and that should be equal to the outgoing current. So that will be equal to I2 plus IL. So don't get messed up with that. Whatever direction you are giving, corresponding to that, we would be changing the equation. Now, what is I1? I1 is current passing through R1. So that is potential difference by the resistance. So at this point, the potential is V1 already described. It would be V1 minus V dash by R1. That should be equal to I2. I2 would be, now the direction of current is from this point to this point. Potential at this point is V dash. Potential at this point is V2. So it becomes V dash minus V2 by R2 plus IL. So it becomes V dash by R3 plus RL. So if we are going to simplify it, then we could find out V dash would be some value. Now if we are getting V dash, then IL would be nothing but V dash by R3 plus RL. So we would be getting that. Now one point I am going to make you clear, that if I am taking this method or this method, if you are going to rearrange the thing, the final expression what you are getting the very same expression. Means finally I would be getting V should be equal to V dash. Why it is? Because we are having the same circuit. So in the same circuit, that potential V and V dash should be equal, because this V1, V2, R1, R2, R3, RL all are constant value. So V should be equal to V dash. So whatever method we would be actually handling, we are going to get the same value of IL for any method what we are going to take. If you are going to take this, if you are going to take this, or if I am thinking in a different way, that if we are having the direction of current is, say, it is going to happen like this one. This is I2, this is I1, this is IL. It may be happening like that. So in that case, what is going to happen? This particular expression is going to change, because now at this particular node I am assuming the voltage VV, and this point is at 0 volt. So what is going to happen? Let me not take V, let me take the V double dash. If you are going to calculate, you are going to find out that V, V dash, V double dash, whatever we are getting the same value. Now, what is going to happen? That incoming current is I2, that should be equal to the outgoing current is I1 plus IL. So what is I2? I2 would be V2 minus V double dash by R2 that should be equal to I1. I1 would be now become, current is flowing from this point to this point, so it would be V double dash minus V1 by R1 plus IL, that would be V double dash by R3 plus RL. So if we could solve the thing, we can find out V double dash will be equal to some value, and then finally, and that should be equal to V double dash, that should be equal to V, and finally we are going to find out IL will be equal to V double dash by R3 plus RL. So since the circuit is same, we are having the same circuit in the tree arrangement, this. So the final current that would be passing through RL, that should be same for all the three. And this is what basically the Kirchoffs current law, and how I could apply this Kirchoffs current law in a particular circuit I had demonstrated. Now in the next video we would be demonstrating that how we could apply this Kirchoffs voltage law to a circuit. If you are having this idea clear, then you can apply that information to any circuit and simplify the thing. So I'm stopping here. Thank you for coming across this video. If you have any doubt, you are free to communicate me. Thank you. Have a nice day.